Hi, my name is Matthias and I'm co-founder and CEO at Tenzir. I'm excited to be here today and talk about how we use Arrow to apply data engineering to security operations. This talk just scratches the surface and gives a breadth-first overview of what we do in the next 10 minutes. At Tenzir, we're building an open source telemetry engine that supports the use case of the security domain. Why are we doing this? Well, on the one hand, we were surprised how much data engineering was needed to make general purpose data warehouses work well for security. And on the other hand, we were struck by how hard it is to embed existing solutions in performance demanding environments. With VAST, we aim to fill this gap. Users of VAST are human security analysts that hunt for threats or perform forensic investigations. Aside from humans, the tooling from service providers interacts with VAST in a more automated way to find out whether the latest threats are present in the recorded telemetry, for example. And we envision VAST as a multi-node system that runs across an entire organization in a federated way. The system should scale both in a centralized public cloud and run embedded at the edge where it can execute security content. This slide has an open fabric in the center that not only VAST nodes can tap into, but also other systems. The backbone of this fabric is pluggable. It could be Kafka, Rabbit, MQTT, or even something IPC-like in tighter settings. When exchanging security content and telemetry over this fabric, the idea is to encode it with Arrow. And let's zoom into one of those VAST nodes in more detail to see where we go in here. The architecture of these nodes within each node is following the actor model. And this is how we structure the application logic. Each circle here represents an actor, blue one for one that can spawn multiple times and red one for a singleton component. And it really resembles a microservice architecture, but process boundaries can be drawn quite flexibly. For example, all actors can run in a single process in an embedded setting or run in a containerized way across your orchestration engine of choice. If we look here at the left path, that's the right path. That's where the data arrives into the system. On the right side, we have an example query that's the read path. And there are several transition points where Arrow comes to play. Most notably on the right path, where parsers transform it into Arrow record batches internally. And the second piece that's important on the right path is the persistence. So record batches are an in-memory format, but once they go to disk, there's a pluggable backend, and for that we have Parquet or Feather-like store. Same thing on the reverse, on the read path, when query results get delivered back to the user. These initially arrive at record batches, but very late at the transition boundary to the system get transformed into something like CSV or JSON. Basic process here is that there's a catalog in the middle. It's also called a meta store. That's where everything kind of comes together. That's obviously the choke point of the system. Scaling that is something we plan to do in the future, considering Raft-like algorithms to make that easier. But for now, that's the central point where queries, receive the set of candidate partitions that can then be ran by a pluggable query engine. So these are the key entry points here for Arrow. And if we look a bit closer at that Arrow data plane, we really have multiple pieces currently at play from the Arrow ecosystem. It's more than just for us a data representation, but that's the element within VAST where once it's onboarded into that representation of Arrow, we can use it quite flexibly in the system and perform compute on it. Right now, we have our own domain-specific type system that we were able to encode in Arrow along with the extension types mechanisms. I'm going to talk about that in the next slide. And from here, really, that once the data is in that Arrow format, we can make use of the entire ecosystem nicely. We're planning to use Acero in the future as an entire engine. Right now, we are using subsets of the Arrow Compute API to call specifically columnar kernels when we need to. We already support exporting data through Arrow IPC. In the future, we would love to do that with Flight as well to get rid of vast fat client and making queries not just Flight as a way to kind of bring them into the system, but also using a substrate approach that would have a query language intermediate representation so that we can then use a pre-processing step to support arbitrary security content queries and do not have to transform those custom query representations into one-offs that run in a specific engine. So it's a nice boundary on the query side. We're tightly following the project and looking forward for the right time to pounce here. Moving closer inside that Arrow data plane, this is the domain-specific model we had prior to using Arrow, and we actually still use it. What I want to say is we came up with this independent of Arrow, and it's basically structured data quite flexibly with the ability to have type aliases, so user-defined types, and attaching custom semantics to types with key value attributes. And then there's obviously some basic types that represent the data flexibly, bool, duration, integer strings, and more complex types that depend on runtime state, such as the number of fields in an enum or a record. It's the most important piece. We map this to Arrow in a one-to-one way, and we can now forward and backward convert it without information loss, but it required some adaptations. So we could model some of the non-existent types in Arrow, like IP addresses as extension types. Also, an enum is an extension type where we encode the possible values in the type itself. And the challenge was really to bring in the key value metadata, which in Arrow is only possible to include in a struct type or in a schema that is basically a struct type plus metadata. So, but now we were able to use that interchangeably and could find a way to represent the exact model that we had in mind. Yeah, that's it for a short overview about VAST, which we are currently here developing at Tenzir, an embeddable engine for processing high-volume security telemetry. For us, Arrow is the key enabler in this. It not only gives us a good representation of the data to work with, but it makes it really easy to bridge into other ecosystems, given there's already so much work out there in the Arrow world. Thanks for your attention. If you have any other questions, feel free to join our community Slack or visit our website, vast.io.